Hello and welcome back. We're going to continue with our development of skills in relation to sketching parabolas using factorization, that is using PSF. And this time we're going to look at an example that's a little harder. This time it's non-monic with no nice way to be able to factorize it, so we can't go and use our monic shortcuts that we've practiced in the last video. But essentially the method does not change for being able to sketch this, okay? So if you remember, we're first going to find our y-intercept. So again, at each step, okay, we're telling the marker or telling the person reading our solution, not just the marker, what we're doing. And we're saying our y-intercept is going to occur when x equals 0. So that's when we end up replacing all of our x's with the number 0, as you can see up here in this particular equation, okay? Noticing that I use brackets around all of my numbers is just a good habit to get into so that I'm not falling victim to forgetting a bracket on my calculator with negatives. Again, because this is a trinomial, so there are three terms, and importantly, it's in the general form, ax squared plus bx plus c. Okay, I know that the y-intercept really easily is just going to be whatever the constant term is, i.e. the number without an x. Okay, the next step, okay, is to go and find our x-intercepts. Now, this is usually the meat of the question, okay? Often this is one of the harder parts, okay? So again, telling my marker or telling my reader of my solution what I'm doing. My x-intercepts occur when I have y equal to 0. So I'm going to let this equal 0. And again, just like last time, I'm going to move the whole equation and shift it round so that we have an equal 0 on this end instead of having it on that end. Okay, so I end up with this saying minus 2x squared plus 3x plus 2 equals 0. Now, to refresh you a little bit, okay, remember again, this is a non-monic trinomial, so we should try and do PSF first and foremost, okay, right? P being very careful here to remember this, that the product occurs when we multiply the coefficient of the leading term by the last term, giving us minus 4 for the product. Please be careful with that. And then our sum doesn't change. It's still 3, the middle term. Okay? So we ask ourselves what two numbers multiply together to give us minus 4 and add together to give us 3. We can say that is indeed 4 and minus 1. Now, we have to be very, very careful here because this is non-monic. We have to go the extra mile to make sure that we split the middle term into these two factors. We can't just jump to the end straight away. So we end up with, depending on how you want to do it, it doesn't matter, minus 2x squared plus 4x minus 1x plus 2 equals 0. And all we've done is we've just split the middle term into the two factors there. So now, because it's non-monic, we look to group in pairs, okay? So common factor for the first pair that I will underline in red is going to be uh, a common factor of 2. So I'm going to drag, and x, I should say. So 2x out the front of minus x plus 2 inside of that bracket. And that's just factorizing out a common factor of 2x and a common factor of 2x. Now I look at the common factors inside of the second pair. And you might be sitting there thinking, I can't necessarily see a common factor between minus 1x and 2. And that's because there isn't, because our aim is just to factorize the brackets to make it look like this particular bracket. So I'm going to drag out a common factor of 1 to leave that particular statement the exact same, okay? And you'll notice here that this is just like me taking out a common factor of 1 for that particular section there. Now we know that we are on the right track because we have both brackets being the exact same. Okay, so now we can collect them as a common factor, and we have 2x plus 1 outside of minus x plus 2 is equal to 0. And I encourage you just to take a short moment just to make it look a little bit neater. 2x plus 1 outside of 2 minus x, just by rearranging the inside of that bracket equals 0. Now be careful here. Often when you get to this particular point with a non-monic, it is often easier to apply the null factor theorem and solve each equation separately, okay? And we can apply the null factor theorem because it's equal to 0. So solving this equation above on the left-hand side, we're going to subtract 1 from both sides, and then we're going to divide by 2 to end up with minus a half. Now, for our equation here, we are going to add x to the other side to make it positive, and we end up with x equals 2 straight away. Okay? Now, a couple of different ways that we can go through and find the axis of symmetry. It's starting to look a little bit less nice with these particular points here. So I'm going to find my axis of symmetry using negative b on 2a. Okay, so I say axis of symmetry when x equals minus b all over 2a. We may just bring our equation down here just to make sure that we don't make a mistake, and I'll keep it here color coded so you can see what's happening. You'll notice here that my b is going to be positive 3 and my a is equal to minus 2. Okay, so my axis symmetry is minus b on 2 times minus 2. Okay, simplifying that out, we're going to end up with a negative divided by a negative, making the overall result positive. So we end up with 3 over 4 being our final answer. Okay, alrighty. So now that we've found our axis symmetry, our very final step is to find the vertex. So our vertex occurs at the axis symmetry. So we take whatever value we found for the axis, okay, and we substitute into our equation, right? So we're going to replace, wherever we see an x, we're going to replace it with 3 divided by 4. So minus 2 outside of 3 quarters all squared, plus 3 times 3 quarters plus 2. And you should take some time to enter this in on your calculator, probably in a few steps, just to make sure that you don't make a mistake. And if you've done it all correctly, you should end up with a fraction being equal to 25 on 8. Okay? Alrighty. So our vertex is at the coordinates 3 quarters and 25 on 8. Okay, so therefore our vertex is there. Now, what I would be saying to you is it's not necessarily easy inside of your mind to visualize how big 25 on 8 actually is to give us a sense of scale for this particular graph. So I will often, if I get particular values, make some adjustments into decimal form just to give me a bit of an approximation of where it should lie. So we know that, and I might do this in red just so we can see that's giving us a sense of scale. We know that 3 quarters is 0.75, but 25 on 8, that's this particular term there, if we plug it into our calculator, is equal to 3.125. So around about 3.1-ish. And this little red section here is just to give us a nice sense of scale when we're going and drawing our graph. So putting it all together, okay, we're going to take each point of our drawing. So we're going to start with our y-intercept being here at positive 2. Our x-intercepts here are at minus a half and x equals 2. So x equals 2 and minus a half. So 2, 2, minus 1 half. And our vertex is going to be at 3 quarters and 25 on 8. Now you might be thinking, well, hold on a moment, that's not underneath the x-axis, and that's correct, because when we go up and we check our particular graph, you'll notice that the leading term here is negative, okay? Therefore, we have a sad parabola, okay? So it's going to be roughly at around about 0.75, and then at 3.125. So I would be saying to you that it would be occurring roughly there at 3 quarters and 25 on 8, giving ourselves a sense of scale to be able to go and graph it. Okay, putting it all together now, connect all of your dots that you've put onto your curve. Okay, and now graph your equation. Once you've done that and you've got a nice, neat, smooth curve, okay, you're all done. Again, following those 5 steps of y-intercept, x-intercept, the axis of symmetry, vertex, finally followed by doing a double check whether it's concave up or down, i.e. happy or sad. Okay, in the next video, we'll have a look at a difference of two squares and a perfect square so you can see how they behave. Thanks very much.